All right. What is this section even called? I don't even know. 3.6. Multiplying matrices. All right. So I'm assuming in the notes y'all got through the stuff that was like the two matrices multiplied together that just had letters in them. Yeah. Was that at the end? Okay. I was trying to make sure that was at the end. So we're going to go through and look at a couple examples here that will help us to see how this works. So the first one say to state whether the product AB is defined, and if so, give the dimensions of A times B. So A is a 2 by 2 and B is a 2 by 2. So I want to know if AB is defined. So the inner two have to be the same. Okay. So since these are the same, it works, meaning that these outer two give you the dimensions of A times B. So it'll be, I don't even know. Oh, this is actually problem 3, just in case anybody wanted to know. I was very confused. It's actually problem 3. It's 2 by 2. I was looking at it and I was like, that's not the answer that it says, but there's no 3 in this problem, and that's why. It's because it's number 3. Okay. Now let's do number 4. A is a 3 by 4 and B is a 4 by 2. So A times B, okay, 4s match up, they're the same. So that means that our result is a 3 by 2. Okay, but suppose I asked you for B times A. That would mean I would have 4 by 2 and 3 by 4. These two are not the same. So this one would be not defined. Does that make sense? How that works? If those words that are written on the board get in the way, just let me know and I can get rid of them if I need to. All right, so then find the product. If the product is not defined, state the reason. So number 10, we have 3, -1, and then 5, 7. So what are the dimensions of this first one? 1 by 2. That's rows and then columns. And then the second one? 2 by 1. So since the 2's match up, my result is going to be a 1 by 1.
Wait, which one comes first, the rows or the columns?
Rows. Rows first, then columns, so reverse alphabetical. I literally, until like last year, could never remember which one it was that came first. So what we do,
So for the 5 and 7, shouldn't it be,
so there's 2 rows and 1 column. So remember, columns go up and down.
I thought rows and
Rows go like this.
Okay.
Like rows go across, columns go up and down.
Okay.
Like think about like the big pillars out front of the church, those are columns. Those are called, yeah. That's the only way I can ever remember the difference in the two. I mix them up all the time. It's really bad. So the way we do this is we do the 3 times the 5. Okay, and you don't have to write this out every single time. When you get to some of the bigger ones, you're going to want to write them out. But you have 3 times 5. Normally it would be plus, okay, but we also have negative numbers in here. And so then it'll be -1 times 7. So that's going to be, I'm just going to write over top of it, 15 and -7. So that means that our resulting one is 8 is the answer, just in that one. Because it's just a 1 by 1. number 12, -1, 0, 5, 4, and 4, -6.
That's a 2 by 2 by 1 by 2.
So I've got a 2 by 2 and a 1 by 2. So can I do this one?
No.
No. Okay, these don't match up, so that means that it's not defined. Okay, and just showing this is sufficient of a reason to say that it's not defined. You don't need to like state in words. The middle two dimensions are not the same, so blah, blah, you don't have to like write all that. You can literally just show that and that's fine.
It's probably the whole paragraph.
Huh?
It's usually probably the whole paragraph.
Give me a funny story to go along with it. All right, 14. Give me a 5-paragraph essay. And I'll take it to Miss Patton and say, can you read this? Because I don't want to. All right, 5, 0, -4, 1, and then -3, 2, 6, 2. So these are both 2 by 2s. So since these are the same, this is my result, is going to be a 2 by 2. I typically will go ahead and I won't even draw in the right side until I'm done because there's so much stuff going to be written in here that I just like to wait. So I'll try to color code this if I can to try to help. So in this first box right here, this first spot, what we do is it's the first row times the first column, and then it's going to be plus, well, hold on, never mind, we'll get there when we get there. Okay, so first row, first column is going right here, so 5 times -3 plus 0 times 6. Okay, so that's first row, first column. That's what's going there. So then I've got first row, second column is what's going in this top right spot. So 5 times 2 plus 0 times 2. So now I come down here, second row, first column. So it's going to be -4 times -3 plus 1 times 6. And then try to find a color that's different. Let's use this weird blue.
So many colors.
You don't have to color code it when you do it. I'm just doing this initially to show you that, like, where the stuff is coming from, just because it can be confusing. So then second row, second column is going down here in this bottom spot. So -4 times 2 plus 1 times 2. And then now you just need to simplify this. But one way to check and make sure that you have done everything correctly is in your first row, your first numbers should be the same. So see how like both of these are 5s and then both of these are 0s. Okay, and then down here both -4, then both 1s. Then when you stack them on top of each other in the columns, they should be, the second number in each thing should be stacked on top of each other the same. Okay, so that's kind of a way to go back. And that's also why I like to go ahead and write the whole thing out. Even if it's like 0s in here, I write them so that way I can go through and check off and be like, yes, no, blah, blah, blah. Anyway, so then now we just need to simplify this. So we've got 5 times -3, -15 plus 0. So -15. Then over here, I've got 5 times 2, 10, plus 0, so just 10. I've got negative 4 times negative 3, so that's positive 12, plus 6, so that's 18. And I will tell you, like, maybe y'all won't have this problem, but a lot of times I accidentally, just because I see the plus sign, I end up adding, like, my 1 times whatever. I, like, add them instead of, so, like, I'll put a 7 there instead of a 6. So just kind of, like, pay attention to that. I don't know why, like, but I do see that happen a lot with people where they'll, like, and I do it too, and it literally makes, I don't understand, but it just happens. And I'll be like, oh, 12 plus 7. And then I can't figure out why my answer's wrong. Then I go back and realize. So just like a common thing just to kind of like watch out for. And then let's see, negative 8 plus 2, so is that negative 6? Now, obviously we did some stuff on our calculator before. If you take and plug these two into your calculator, you can verify them. So if you want to check them, and just to see how it works. So remember, you go to second and then hit matrix, go over to edit, and then you can type them in. And when you go to multiply them, if you were showing me that you did it on your calculator, okay, obviously for these ones, I'm going to make you do them by hand. But if they get obnoxious, like on the test or quiz or whatever, I'll say like, okay, on this problem, do it by hand. Or on this problem, do it with your calculator. Like there may actually be a separate calculator page on this test. But if you are doing it on your calculator, what you need to write is like, show me that you did like matrix A times matrix B. That clues me in that you did it on your calculator. So when there's not work, I know why there's not work. Okay, and then you would just show me. You don't have to like write down what you typed in for A and B. You would just need to give me the result. So then you would just literally on your calculator do them in that order. And I got the same thing, so we know we did it right, basically.
Pretzel's good.
They're free.
All right. Were y'all able to get it on your calculator?
Yeah.
Good, it works. It's in the video from the other day.
What is it? Oh yeah, second matrix
All right, what I'm going to have you all do is I'm going to have you guys try this one on your own on paper first, just to see if you're understanding how to line them up, and then I'll go over it with you. to go ahead and start writing it out just so that we don't take up so much time. But y'all can just use mine to look at and check in a second. We'll just talk about it after. Alyssa or her mom, I can't remember which one, made him. I just want y'all to know I almost did this again. I literally went -16 minus 6. After I just said watch out so you don't do that. Literally almost did it myself.
I was waiting for you to be.
That is where y'all will get like all your cookie points. Is because I will add instead. 4, and I almost did it right there again. Brain function. Okay. Now what y'all got?
Yeah.
Oh, beautiful. I don't have to I'll have to check it. So again, I just did first row, first column. Okay, and then first row, second column. Second row, first column. Second row, second column. And then just add
once
stuff
you get,
together.
like, which ones are supposed to be multiplied by which,
Yeah.
and you don't mess up, that is...
Yeah. I mean, it gets a little crazy when you have like a 3x3 because what happens is like, so you have 3 rows and 3 columns, so you have 3 pieces
Oh.
here. But what I do is I let you use a calculator for anything that's bigger than a 2x2 being multiplied by, like, anything that's going to result in something bigger than a 2x2, I let you do with a calculator.
Will you tell us on, like, the quizzes and tests and stuff?
Yeah, like, I'll tell you, like, that's why I said I'll probably have a separate page entirely for the calculator ones.
Okay.
Because a lot of times that happens where, like, I will know when I give you a problem that this is going to be something I'm going to let you use your calculator for, but I don't want to tell you up front, like, I don't want to tell you up front necessarily, like, oh, you can use your calculator, because then you know it's something big. Like, I want y'all to actually have to, like, think about it. Like, so I give you, like, 2 separate test things for it. And then sometimes if I do let you do it on a calculator, I will say, like, on this particular problem, if you also do it by hand, like, I might give you a 3x3 times a 3x3 and say, if you also do it by hand, I'll give you, like, a bonus point or 2. Just like a FYI. So, like, if you want to try a couple 3x3s by hand, like, on your own time, that's fine, but I'm not going to assign you any to do by hand that way. 22 through 29, it gives you 5 matrices. It gives you like A, B, C, D, and E, and they're all different values, the dimensions or whatever. And then it'll give you a problem like, I'm not actually going to do it because I don't want to take that much time because I think y'all are good. It'll give you like AB plus AC. Literally just type all 5 matrices in your calculator to begin with, and then just do whatever the problem says to do. And just write out AB plus AC and then equals whatever the result is on your, like, when you're on your calculator screen. Because that way, I trust if you can do the couple that I'm giving you by hand, you get the process and you know what you're doing. So that way you're not doing like an obnoxious amount of those. And feel free to check any of them on your calculator even after you do the ones by hand, like, to see. I mean, obviously the back of the book has them, but so by hand, you need to do 3, 7, 11, and 13. And then on your calculator, do 17, 23, 25, and 27. The only thing I will say about these ones is make sure, I can't remember if for matrices if your calculator can do order of operations on its own or not. You may need to like parentheses off the two separate things. Like, because if you just put this in order, your calculator for some reason isn't smart enough. If you don't put parentheses around stuff, it'll do A times B plus A times C.
Oh.
But I don't think it does that for matrices. I think you can plug the whole thing in and it'll do it for you. But you might just want to verify with the back of the book that it does it right for you when you do a problem like that. So, any questions? Yeah, it's 199 and 200. So, like, for example, something like 17 might be something that I tell you, hey, you could also do this by hand to get like an extra point or something on a quiz or a test. The other thing is sometimes on a calculator page, I will still give you one that's not possible. Like that can't be multiplied. And inevitably, rather than check it beforehand, somebody will just type it in your calculator. And then you're going to come up to my desk and say it's not working. Because your calculator will read something about error, dimension, something like that. If you see that when you do a matrix problem, it means that the dimensions don't match. You can't do the problem. Verify that you have your matrices typed in correctly to your calculator. If it reads that same, like after you verify, if it reads the same way again, be like, okay, clearly the dimensions didn't match, and then go check for yourself to make sure. But that's why, like last year, it was so funny during a quiz. I had like 5 people come up to me on the calculator page and say, this problem isn't working. And I was like, if it's not working, what does that mean? And they're like, I don't know. I'm like, go back and look at the problem. And then all of a sudden you see the light bulbs go on like all across the room. They're like, it's not working. Oh, duh. Like, anyways, it was just kind of funny. But that's what I was going to say. Like, if you see that message come up, that's why.